I'm going to give a quick, brief, high-level view. This is a 30-minute talk. I normally like a good 90, so I'm just going to give a 90-minute talk in 30 minutes, so I hope you're ready for that. I'm going to really, I know as I've talked to some of you on my way up here, you've been at some of my talks before, so a lot of the content will be the same, but I always like to keep it fresh, mostly for myself. And so I'm going to really place a little bit more emphasis on this idea of experience as the basis of how technology could play a role in what we're all doing here, which is, try to improve the human condition. This is basically the idea that drives pretty much everything I do. I'm going to give you a tour through both my academic work as well as work in industry of this concept of enhancing human cognition. And, I'm defining this very broadly. When it comes to both assessing and optimizing how our brain functions, cognition, thinking about attention, perception, memory, but also our reasoning and decision-making and imagination, creativity, how we regulate our emotions, how we feel empathy and compassion, how we have wisdom, we're really tragically lacking. And you can think about this both from the clinical side and from the non-clinical domain. In the clinical domain, we know that there's 500 million people around the planet that are suffering debilitating effects of anxiety and depression, deficits of attention and memory, and these numbers are rising, notably for our seniors when it comes to dementia and cognition, but also for our youth. With emotional regulation as well as attentional regulation. If you look outside of the clinical world, you see similar issues of people struggling a lot. So much so that I would say that we're actually experiencing now what I view as a cognition crisis, a crisis of our minds, and one that seems to be getting worse. It's a complicated, long discussion about why this is and how we could manage it, but I have come to believe that we need to think about this goal of enhancing human cognition in the breadth that I just described it to you as a big, grand, global challenge, placed right up there with other pressing global priorities. And the reason why is because if we cannot manage to focus our attention in a sustained manner and make wise and creative and future-oriented decisions that prioritize others over ourselves, we will never effectively address other complex, time-delayed crises like climate change. No matter how much information we acquire, we will not be able to deal with it. And you could see a lot of that happening right now. So it would seem that we're well positioned to deal with such a crisis, given that we have these big, multi-century institutions of education and medicine that should be well positioned to address this crisis. Now, normally I spend a lot of time, like at least 20 minutes, breaking down the hurdles that we currently face in our education and medical system that prevent us from getting there. I don't really have that time. I'd love to show you some new stuff that we're working on, tell you about some new data. So I refer to you, I wrote a piece that should be freely available called The Cognition Crisis that really breaks down where we have these very, very fundamental challenges in these systems that we haven't overcome. Where I want to spend our time, given the focus of most people here, is how technology could play a role. Here's my one slide that's really singing to the choir here. This is a quote from a friend of mine, Jon Favreau, who's a Hollywood producer, director, writer. We did a fireside chat on virtual reality and storytelling together, and he says, I want to find the humanity in the technology, which I just love. He uses a lot of really cutting-edge technology in his movie creation, like virtual reality and The Lion King, which he just directed. But this is such a big, broad, beautiful message that I know this audience knows so well. It's why we're all here. So with that as a sort of framework, how do we think about technology in this way? And it's such a critical time to have this conversation right now, because as this audience knows better than anyone, we have the consumerization of virtual reality, augmented reality, other types of mixed realities, motion capture, wearable physiological devices, and of course, machine learning algorithms. How do we wrap our heads around both the challenges offered by these new technologies as well as the promise for these technologies to enhance human cognition and lead to all the benefits that we're all hoping to gain? When it comes right down to it, the entire basis of why this is an interesting discussion or an interesting business focus at all is because of experience. Right? Experience is the gateway to our brain's plasticity. It is not the only way that we drive plasticity. The brain also has repair responses to damage, but experience-dependent plasticity is really the cornerstone of how we view all of brain development, including throughout our lives. a tremendous amount of basic science data. They're an understanding and dissecting the physiological, chemical, and structural neuroscientific basis for how our brain is constantly responding to experience. It's really interesting. We don't really have the full taxonomy to even manage deep discussions on experience as something that you could manipulate and create to guide healthier brains. So that's something that I expect that we'll see a lot more of over the next decade. But experience as a treatment and as a way of improving brain function is as ancient as it gets. Two that I like to emphasize is meditation and mindfulness practice, which obviously has deep contemplative roots and an entire topic in itself. The other experiential treatment or medicine that exists is just exposure to nature, which is as evolutionarily rooted as it gets. And I'm going to come back to both of those. But thinking about those in the context, as well as other experiential treatments in the context of technology, how do we unite these two? And I sort of subtitled this talk, Exploring the Role of Technology. So there's many ways that we could unite technology with experience to lead to benefits. But the one that I would say, obsessed with, and if anyone has ever heard me talk, I'm like a broken record for the last decade, about the closed loop system. I've heard it several times today in other talks, so I know it's like really penetrating, and many people are already adopting this in their own development. So for those of you who do not know, a closed loop system is where you intervene in any way and record the impact with as low latency as possible. So ideally in real time, you're reading out the metrics of what you're inducing, and then you're using that data to refine your intervention, also in real time, applying it again and cycle over and over again. With each pass through the closed loop, you're becoming more targeted for the outcomes that you're trying to yield. We have closed loop systems all around us. The cooling and heating system in this room, the thermostat is a closed loop system, sensing the ambient temperature in the room and then adjusting in real time based upon that data, cooling or heating systems to maintain an equilibrium, a homeostasis. We have these all over our bodies naturally, but can we use technology to create closed loop systems to improve cognition? That has been the topic that sort of consumed me for the last decade. And I really became very interested in the idea of doing a closed loop system by interactive media. So here's a cartoon that many of you probably already saw that really serves as a basis for everything that I do, both in academics and outside in industry. So our brain is playing a video game. Of course, it's our brain playing the video game, moving our body, and our behaviors are creating performance metrics. These can be recorded with all sorts of sensors, even like on a tablet from the accelerometer and the tap screen, that records your performance in real time. This data can then be used to update the environment in two main ways. One would be the challenge that you're experiencing, and because it's based upon your real-time data, that challenge could be right in the sweet spot, what our game designers would call the flow state, where you're not so frustrated because it's too difficult or bored because it's too easy. The other thing we could do in real time in terms of environmental updating is give you rewards. This is how you create deep immersion in the moment. It's that immersion that really drives the plasticity, right? So just to be clear, the mechanics of a game or any type of interactive experience is what activates brain networks selectively. We have never activated brain networks selectively any other way. No drug has done that, no electrical stimulation. Our brains work by engaging in experiences, and that's how the brain responds. It'll be a long time in the future, one that we will probably not be around for, where we're able to engage networks with the selectivity that we do all the time just by having experiences. So you could guide the mechanics to activate the networks you want, and then through the closed loop, you can apply pressure to that so that your brain's own inherent plasticity systems optimizes its function. Of course, it creates a great deal of importance on what type of mechanics, what you're trying to optimize for. This is also a great system to bring in all the other technology I described to you. So with motion capture and physiological recording, we can get a deeper insight into how you are reacting in the moment, your state, which is often invisible to you and a therapist, let's say. That data could then be fed into the software engine to create a more targeted experience to you at that moment. And then, of course, advances in virtual reality and even augmented reality could be used to create more real-world environments. The hypothesis being that if we put you in a more real-world environment, we'll create greater outcomes. But that's still largely a hypothesis. The other thing we could do is wrap all of this together, this very, very complex, multivariate data stream that's flowing from this processor into that processor and back again, great opportunity for machine learning, especially like reinforcement learning. So I always say this is the ultimate use for AI, right? AI for HI. How do we use artificial intelligence to advance and enhance human intelligence? And I think that this is exactly the way we'll see more of this. Now, we don't have this right now. We have the pieces of it in a lot of the projects we're doing and others, but we're putting that together. So this started for me a decade ago. I'm not going to tell this story in detail, but I came up with an idea for my first video game, a closed-loop video game that we called NeuroRacer, to improve attention and memory in older adults. I've been, at this point, a neuroscientist for 20 years studying aging and the declines that we face as we get older, independent of things like dementia. We built this game with friends from LucasArts and did 3 years of research. Took us a year to publish it, but eventually published in Nature in September 2013, sort of like a life highlight for me, the cover of this journal, which was an incredible moment. But for us, it was a real, us meaning like the 40 people working on this research study, it was a real grounding moment in that our goal was not for a high-profile publication. I mean, obviously, we all want that. It's how academics works. But the goal here was really to get this technology into people's lives. Now, this study started, so this idea of a video game came to me in 2008. We're now 11 years later, and I'm sad to say it is not in people's lives, but I can tell you that I firmly believe it will be there next year. So it's been a long, long journey, and some of that is just the complexity of what we've tried to pull off, and a lot of that will become more obvious in the next several years. But the idea was twofold. How do we advance both the industry side of this story and the academic side? So let me tell you the industry side. First thing I realized is that we cannot build a scalable product at my university, at University of California, San Francisco. I would say that no university is really equipped to do that, right? We're instantly out of date in terms of our operating system and our hardware that we're using. We just don't have that capabilities. It's not what universities are best suited for. And so for that, that's what companies are well designed for. And so I started a company called Achille Interactive with friends from the video game world, largely from LucasArts, as well as a healthcare venture group in Boston. So Achille Interactive is a company that really I patented. So I patented the technology behind what you saw. You can't really patent a video game, right? You could patent the methodology behind it. How do you weave together those closed-loop systems of both challenge adaptivity and reward feedback? That is owned by my university. That's the relationship between us faculty and our university. We create it, and they own it. And then Achille has a license on it. So three-way relationship: inventor, owner, licenser. So that technology has now been advanced to video games that are way, way more fun, engaging than our original. We've learned a lot over the years on the value of art, music, story, reward cycles, very, very fast adaptive feedback systems. And so we have this beautiful game that we've been building over the last 6 years that no one in the world has really played yet. And why is that? It's because we had this bold, ambitious idea to see how far we could take it through multiple clinical trials to bring it to the highest level of scientific validation as a diagnostic and therapeutic tool. And so there are multiple trials that have been going on for many years. I'm actually not a primary on any of these trials. But they've all been advancing. Some of them are diagnostics to use the video game as a sensitive tool to understand behavior, but most of these are acting across therapeutic goals in these conditions. The one study that I love to pause on, it was led out of Duke. I was not a researcher on this study, but they used the game in what I think is the most ambitious study in this field to date, which is a prospectively designed, multi-site, double-blind, randomized, placebo-controlled trial on a video game in children with ADHD. There's 20 sites, 350 kids. The study is done. It is now in review for publication. Very exciting. The primary outcomes were pre-submitted to the FDA, which is the sort of most rigorous approach you could do for approval. This is being positioned right now as a Class 2 medical device to treat attention deficits in children with ADHD, which, if it happens, would be the first ever cleared video game by the FDA. So we'll see. We're working through that process. It is a longer story. I could tell you that the FDA is just as backwards as you might imagine them to be. One day I will write the full story, but not today. But that's what's happening. Now, whether or not, depending on how this goes, we will get this to kids. There's a much, much longer, complicated discussion. I think one of the earliest speakers spent a good amount of time breaking up all the positives and negatives of the consumer versus medical route. It gets really complicated when you have a treatment like this that has virtually no side effects. The main side effect in our phase 3 trial was actually frustration, which is, not so bad when you consider all the other side effects. So we'll return to this topic, but that is very exciting, and next year you will definitely see this in the world. So I'm happy that that's going to happen. Let me go back to the academic side. My laboratory, no one at this point wanted to do basic cognitive neuroscience anymore. Everyone wanted to do what we now think of as translational neuroscience. How to use the insights and the methodology from neuroscience to guide real-world products, things that can actually help people in the short term, and bridge this gap that we see existing between the technology world, specifically the non-invasive consumer-facing technology world, and neuroscience. And so just a quick flyby Neuroscape. This is what our laboratories look like, and our control room over there on the top left. This is also baked right into a larger research unit. We have 3T MRI scanner right outside one door. On the other door, we have a phlebotomy suite for blood draws. We can run full phase 3 trials here and record pretty much everything you can imagine during a interactive experience that's designed as a treatment. We're now building these labs all over the world, most recently Switzerland and Nice. Just got back from a trip to Shanghai. We're building 13 more of these at UCSF. So really exciting. A lot of people are embracing this, and we realize that we need a laboratory that's actually designed to do these types of studies, because the traditional laboratories don't really have the equipment and the approaches in order to do very high-level research. So that's exciting. How do we think about new laboratories built around experiential treatments? And that's really what I've come to think about this. If you've heard me give a talk before, you probably have heard me use the term digital medicine. I still use that term. I think it's really sort of a cool way of thinking about the digital world, digiceuticals. But what I've come to believe is that the digital part of it is really like our pill. The treatment, the real treatment, is the experience. That is what's driving the effects. Like a pharmaceutical uses and creates its effects through molecular treatments, these drive their effects through experiential treatments, experiential medicine. So that's what I've really come to embrace more. How do we break down all the elements of the experience that lead to the maximal positive outcomes? Just to show you a little bit of the things that we're working on that we don't always talk about, I try to show a little bit of different things each time. We've spent years developing a cognitive evaluation that uses closed-loop systems. So a closed-loop system is a very effective way to sample any ability. Matter of fact, it's the basis of hearing tests. That's where a lot of the adaptive staircase algorithms that we use were really developed. So you go up, 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 you can't hear it, you go down, 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 you find that sweet spot, you get a threshold. The beautiful thing about using adaptive closed-loop systems for cognitive assessments is that there's no ceiling or floor effects. So you can use the same test for all types of people. There's no perfect, there's no, perfectly bad, it's just you threshold that ability. And it leads to a really exciting opportunity to put these type of devices into the real world. We're very, very motivated to get them into the real world. And so you could see here studies that we've been doing in classrooms. We did a study with the support of the NSF of 1,200 students in school, understanding the profile of their cognitive abilities so that we could connect how their cognition is at any given moment and their academic performance metrics like reading and math. Believe it or not, we don't really have those connections yet. It's sort of dizzying to realize the disconnect that exists in the education world between neuroscience and learning, but it's there. And so if we had a profile of each student's cognitive abilities across the full breadth of it, can those then be levers that we could push on to allow them to reach their maximal potential? That is not happening right now. So you could have a student that's not going to be diagnosed with ADHD or dyslexia or some type of learning disability, but yet we're not really assessing their cognitive abilities. And maybe they're masking a weakness by their other strengths that's now being totally missed. So that's an exciting application of what we're doing on the assessment side and how we think it could have benefit for our education. We're also like to imagine this idea of virtual reality. The idea that it is a head-mounted display is not true, right? I mean, the visual system is only one of our sensory systems to create the impression, the simulation of a reality that's not actually there. It's really the full sensory immersion as well as the idea that we move as human beings, perception and action cycle. So that's something we're very excited about, is pushing that to where we think it will have the most impact, is what virtual reality, is and should be. Over the last now 7 years, we've been building multiple interactive experiences as medicine. We'd say as experiential medicine. Body-brain trainer, Engage, Rhythmicity, which now has a follow-up game called Coherence, Virtual Attention, Labyrinth, Metatrain. The world has not seen almost all of these except Metatrain, which I'll tell you about in a moment. Each of these are targeting different cognitive systems through different types of interactive experiences. They all, at least to some degree, involve art, music, and story, which we think are critical for the engagement to harness our brain's plasticity. They also all use different types of hardware and sensors to create these closed-loop systems. So Body-Brain Trainer, which is in the middle, on the top over there, you play a game that's challenging you cognitively and physically at the same time, but instead of the closed-loop systems just being driven by your performance, they're also being driven by your heart rate in real time. So before you be in this study, you do a VO2 max, we find that perfect anaerobic threshold, and then the game knows your heart rate in real time, so it can change the amplitude of your movements to drive your heart rate up or down, to titrate it just to that perfect point. The hypothesis being that if we challenge you in an embodied cognition environment, will have better cognitive outcomes than if you just play that game sitting on your butt. So that's the idea behind that particular one. We also have games in VR, as well as games where we stimulate the brain. We had a talk earlier on neuromodulation. Here we use a type of neuromodulation called transcranial alternating current stimulation, where we target that stimulation to endogenous brain rhythms to enhance the effects. We have 3 published papers showing that we can accelerate your learning curve on a game within the hour that you're playing it. And now we're going to the big win, which is to understand, can we induce greater transfer effects and better, higher levels of performance and longer lasting benefits by brain stimulation during gameplay. So that's a little sneak peek. And then, the dream is not to build silos around these as we've seen now, but to do what I think of as neuro CrossFit training, right? To understand someone's state and their baseline in a very deep way, and then give a whole series of games that are all personalized to them, and then all evolve with them over time because of the closed loop system. Now that we've built all of those games, we do a really, really deep dive into understanding how they work. It's been a journey for us to understand the methodology of doing double-blind randomized controlled trials on video games. We feel that we really have dialed that in now, even way beyond what we've done with our 2013 Nature paper. And so if you were going to be in one of our studies before you engage in, let's say, 6 weeks of Metatrain, our meditation-inspired game, you would get an MRI scan looking at function and structure, an EEG test looking at brain dynamics in more real time, stress testing, mood assessments, blood work looking at inflammatory markers, telomere length, hormone levels, anything we believe might change from before to after we study, and see how that changes against a placebo control group that's matched based on their expectations that they'll see the same type of benefits. And then we move those, hopefully as rapidly as we can, into the world of education and medicine. And the goal here is really to take advantage of technology to overcome those hurdles that we see in the education and medicine system now. Targeted, personalized, multimodal closed-loop systems. That is what we do not currently have in either the mental health, medical domain, or the education domain for improving cognition. So that's the ultimate win, is that we achieve that goal. I just want to tell you about Metatrain. I don't really talk about this one, but it's now published. So it's been a long time between publications for us. As you can imagine, it takes us 2 years to build every single one of those games before we even start doing the 2-year research study. So this is like a 5-year process for Metatrain. It was actually funded by the NIH. It takes the principles of concentrative meditation and integrates them with closed-loop adaptivity of challenge and reward. Our big partner on this was Jack Kornfield, who you might know is a thought leader in the meditation mindfulness space, the founder of Spirit Rock, up north from here. And we created this game, and then we did 3 randomized control trials, one on healthy 20-year-olds, which is now published. And what we showed here, so this is a Nature Human Behavior, it's maybe at 2 months old. And what we showed here is that we can improve multiple measures of attention in healthy 20-year-olds, also recording brain activity before and after, and show the networks that are involved in that improvement. We now have a paper that's in review showing that we have the same benefits. We replicate that study in children. These are foster care children with adverse life events in India. Our goal here was really to to show the accessibility of this technology, getting this in places where we struggle getting doctors or teachers. Again, same benefits on sustained attention. This was an fMRI study showing also the change in networks that occur in these children to lead to these benefits. We have a third study replicating the finding again in healthy older adults, showing these benefits in sustained attention. And here we're doing a deeper dive into the blood work to understand the changes in inflammatory systems as well as telomere length and other changes in brain activity. So that's MetaTrain. Just using it as an example, all those other games are now in that process of going through the series of randomized controlled trials in different populations. The glass brain, no talks complete without a glass brain video. So this is part of a bigger program, which we call a multimodal biosensing program that we're putting a lot of attention to right now. This is actually my brain you're looking at. It's a combination of both MRI, which is done all in pre-processing, the cortex in blue, the golden fibers are the white matter that connects different brain areas, and all the different colored lights and the streaming activity that you're looking at. There's different rhythmic activity in my brain while I'm playing a game that we were able to get down to just a 200 millisecond delay. So multiple processing occurring in real time from obviously Fourier transformation, but also source localization, artifact correction, and multivariate range of causality here. Now, I just put this up as an example. It's really a work in progress, but the goal is not this alone. The goal is to integrate this with everything else that we could record from someone in the moment, from their electrodermal activity, heart rate variability, their pupil responses, and more, that we can really understand the state of an individual in the moment. So that's the goal, because most of it is still a black box to us, and we're really looking at what happens before or after. Once we have this, and we're working on this, this becomes the ultimate way to close the loop. Because if we can understand how someone's brain was processing information in the moment, we could use that data to guide the adaptive aspects of our programs, right? The challenge and the reward, not just on the end product, which is how fast you are, but the processing stages that most need to be optimized. We can also use this data to guide the parameters in transcranial alternating current stimulation. So if we understood, where your frontal theta was at the event-related moment of engagement in a particular environment, we could then stimulate at that perfect amplitude of that power of that rhythm for you. So that is where we're going with this type of technology. All right, I'm just going to conclude. I just have a couple of minutes left to tell you where we're going. Some of you have seen this. I haven't actually talked about this on stage many times, I think only twice now. But I'm really, really fascinated with the idea that nature has, a long history, obviously, of being used in the real world as a restorative tool, but also the potential that it could be brought into this domain, that technology can be used to deliver it in a way that creates some of the benefits. And those benefits have been recorded across a whole host of different outcomes, right? So from stress relief, attention restoration, mood, anxiety, stress, and sleep. So there's a lot here. How do we accomplish that? We've had some sort of low-level attempts at seeing if we could create natural environments that have these benefits. But really, I think the answer is through this concept of sensory synchronization. So sensory synchronization is when you receive stimuli from all your senses in unison. And what that does is it creates an electrophysiological phenomena in your brain that we call multisensory integration. It means that the different cortical areas in your brain, although they're specialized, actually have different responses if multiple senses are being delivered to you at the same time. This creates a phenomena that we call the unity effect, which is this perceptual construction that things around us are entities, right? That there's a place, that there are people, that there are objects. And it's such a powerful effect that if we manipulate it even slightly, it creates these incredible illusions like ventriloquism, where you have locked in time the sounds but differentiate the spatial information. And even though you know that wooden head is not talking, it really, really seems like it is. So it's a very powerful phenomena of our brain. And so this is what I'm excited about. How do we raise the bar on sensory synchronization to create a new type of virtual reality, one that we have never experienced, and then its potential to be a part of this experiential medicine. So a new company that I helped create called SenSync, which stands for sensory synchronization. And the idea is to build a hardware device that really delivers the type of stimulation that, that is synchronized that could lead to that transportation of you into another type of reality. So I think of this as a sensory immersion vessel. In many ways, it's the opposite of a float tank. It's not really an isolation device. I really hate calling it a pod. This is a vessel. It's like a vehicle for your mind that transports you. It's actually all built, although that was a design document. This is a prototype. This is actually located right now at the Four Seasons in Oahu. It's a whole longer story that I don't have time to break down for you right now. But the goal is to create a device where you could see, hear, smell, and feel nature experiences. And the tactile, from vibration to wind to temperature to proprioception to body movement, all of this is possible while we're recording real-time physiological data to create a closed-loop nature experience. So that's what this device does. That's the goal, to really raise the bar on how we create a sensory environment in a closed-loop manner to lead to the benefits that we're talking about. So to put it together and to conclude, there is so much more to do with software and machine learning algorithms in terms of delivering these experiences to have the impact we're looking for. And there's so much more to do on the hardware side. So how do we create really the ultimate delivery platform for experiential medicine? I'm not saying these are them, but that is my goal, is to build these. These are actually separate companies. Neuroscape is separate from all of them. My dream is that these are all going to meet up in a decade, right? I'm sort of playing a chess game with the future here. Hopefully, all of these are going to come together to create this next level of experiential medicine. And just to conclude, I think this is this going public? I don't remember that. Maybe. Okay, well, I'll take a chance here. So this is also a really exciting opportunity to bring another experiential medicine into the mix. So this is a molecule, right? So you might think, oh, that's molecular, this is experiential. I would say that most experts in this field and most practitioners of all sorts realize that the outcomes, whether positive or negative, are largely influenced by experience. The experience itself, the context, the set and setting, all the elements that wrap around the molecule to really lead to the outcomes. And I am very intrigued by that. The ability of us to record with devices like this what is happening during these types of treatments. And ideally, understanding how we can manipulate the elements of context, smell, visual, auditory information to create the first ever closed loop psychedelic treatment experiences. That would be my dream, that we could really do something very valuable there. Thank you. So lots to do. I love this audience. This is like my favorite place to speak because everyone here just is already completely dialed in. Anyway, thank you so much. Always a pleasure. Thank you.